Click the button. Big rocket, go now. Should be live momentarily. Live stream is starting soon. Yeah, it should be starting now. Okay. Welcome everyone again to another Dan Does Data. We're done with Cafe. That was so last week. We are now going to be looking at a new research project. We're actually not looking at a piece of software. We are starting a new project. And so today that just means really getting familiar with the data set. So you might wonder, what the heck are we going to do? I'm going to read in a whole bunch of lines of Shakespeare's plays into various fonts. And then I'm going to make each line sort of its own picture. And the goal will be to try to use that picture to figure out what the font is. And I have a couple of different ideas on how to do this. I actually want to try to use a recurrent neural network with like slices, and in each slice I'm going to do some convolutional stuff. Because like a font has different pieces and parts of it that are interesting. I've already made the data set, and that actually took a little bit of time. So I'm just going to explain what it is, and then hopefully today we'll just try to read in this already created data set. And I'm going to publish this whole business on GitHub, so anyone can take a look at it and tell me what's terrible or awesome or whatever. It's not there yet. It is in a Git repo, but that's only locally. So let me just walk through how I create the data real quick first. And then after that, we'll read it in and start just poking around at it. I don't think I'm going to build any models tonight. Maybe I'll build something really basic. Okay, let's just get started with imports. So we're going to start with pill is our image library in Python. This has actually sort of been deprecated and superseded by pillow, another library. But I'm just using pill because I happen to have it, and it does what I need to do for the purposes of making some images. So we're just going to import a couple things in there to basically draw text, draw the image, and hold the image object. Glob, this thing, that's just for reading in files from the file system. I say reading in. So you can use an asterisk on the file system in Linux and get all the files that match that wildcard. OS is just Python operating system, so we can actually not open the file. What do I use OS for? That's a good question. Oh, I use it to fiddle with pass. Well, there you go. Math, because I need to take, I think I need a ceiling operator somewhere. I need to take a float and turn it into I need to take a decimal number and turn it into like the integer bigger than that, further away from 0. Iter tools, I don't know if I even actually use iter tools. I don't. Alright, I'm deleting that. I apparently thought I was going to use it, but didn't. NumPy, of course, for doing all kinds of computations on arrays. Here's one you might not recognize, H5Py. So there's a data format, it's like high density format 5, HDF5. That's for storing data in a very big data sets in a very compressed way, and you can sort of have some directory structure inside this compressed data file. And there's easy ways to read it and write it using this H5Py. And of course, TQDM is just my progress bar for when I'm doing things. I'm not actually going to recreate all the data here, so I don't actually know why I'm even running it on the left, but that's okay. You're going to have 5 fonts. You can use whatever fonts you want for this. Any kind of OTF fonts are fine. Let's just take a look at those. We're just playing around. These are some freely available fonts on the web. I think they were open for whatever use you want. We'll take a look at them proper later. And then I've got apparently 100,000 lines of Shakespeare. So I downloaded a corpus of Shakespeare text. I think you can do this you can grab it from Project Gutenberg or almost anywhere. That's single pages. What if I just search this? I found it, but I'm trying to remember the website I found it on. T8. Yeah, I got it from MIT, this website, t8.shakespeare.text. Actually, let's take a look-see. Well, I'll tell you, we're not going to look at that specifically. So that's the file name, Bill, for Bill Shakespeare, of course. Num characters, that's going to be how many characters I'm actually going to keep around of each line. I originally wanted to keep all the characters of every line, but storing those as images get to be pretty big. Bigger than I wanted to deal with on my local machine, and bigger than I wanted to read in. You can do it, it's just I didn't want an enormous project. I wanted a large project. Okay, so what are we going to do? We're going to open up this file bill, and I'm going to store each line as like a phrase, the first 16 characters. And I've got this special if clause on my list comprehension here. If after stripping out the beginning and ending spaces, if I have at least 16 characters, keep it. And if it doesn't start with a whole bunch of spaces. And the reason, although, now that I think about it, it's not going to start with spaces if I do l.strip. Right? Because if you do string.strip, leading and trailing white space removed. So that's probably not necessary. Although, yeah, that's definitely not necessary. Let me remove that. So let's run this just so you can see what we're dealing with. So that's all the phrases. There are just over 100,000 lines. You look at phrases 0, you say this is the 100T. 1 is presented in the... So this is a whole bunch of... It starts with a big like license, because it's just an open source kind of thing. If you look at, say, phrase 1000, you start getting some actual Shakespeare. You know what? Let me bump this up to 32, just so you can see a little more. So twice as much. For that deep wound it gives my something, 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 or the other. So that's just text from Shakespeare's plays, one line at a time, and just 16 characters at a time. So what do we do with all that? I want to make an image of each line of text in every font. And we'll be using those to train whatever model we're going to build to be able to recognize parts of Shakespearean text, recognize the font. And then maybe if we were going to have a lot of fun, we could take handwritten lines and try to guess, well, which font is someone's handwriting closest to using if they write Shakespeare. So first we gotta write that font. I went with a font size of 12, and I'm gonna stuff that into an image that's, I think, 16 pixels tall and 128 pixels long. And this was, again, a compromise I had to make. I wanted them to be like arbitrarily long, but then it becomes a pain to store in the file format. So if you've got pieces of data that are all the same size, it's very easy to move between them. If I want to advance one data point, I just move whatever that size is. If I want to advance 100, I just move whatever that size is times 100. So this is sort of the principle of databases in general. But if all your data points are different sizes, then you have to look up at each one. How big is this one? Okay, move that far forward. Look at the next one. Okay, how big is that? And you have to jump very slowly. So that becomes a big pain. So I decided, fine, I'll just make them all the same size. I don't want to build one giant model that just looks at this big image of 128 by 16 pixels, which isn't that big in all reality. But I don't want to do that, right? And so how much data are you going to end up with here? You've got however many fonts times however many phrases. So you've got like 500,000. What, phrases is only so long? Hang on. Hang on. How did I lose these guys? What? Oh. I need to... Some of them don't have 32. Right. Gotta read that. Yeah, so I've got like 500,000 data points. So, you know, we're working. It's respectable. Oh, I always forget to submit to Reddit. There we go. Boom. Hello, Reddit. How are you doing? Okay. What are we doing after that, then? Well, now I just need to save every image that I create to this H5 Pi, or this HDF5 file format. So I open up a file that does that, this fontdata.h5, as you would expect, and I just walk through it for every font, save all the images. So let's suppose, I'll just do an example line here. So f equals fonts 0. So we'll create this fonts object here. Image font.trueType, because it's an OTF, and you tell it what the font is, or like where the font is, the file, and you pass what the font size is, and then you get this font object in pill. What can you do with that? You can ask, what is your name? It says it's this thing. You can say, how big is it? You can do font.getSize as well. Missing. Oh, and I think you can pass in a text, and it'll tell you how long it is by how tall it is. I think if I say like GUI, what's a big tall letter? Yeah, so that's a little bit. That's actually a little bit bigger than 16, my maximum size. So I'm gonna end up cutting off some of the text here on these Y's. Thankfully, there's a lot of these and thous, and not a lot of yous and y'alls. So we should be okay in that. I get the base name here. So base, of course, just extracts the final, like the actual name of that file or whatever you're dealing with. That's a part of built-in Python. And then what is dset? hdf.create. Oh, okay. So this dset business is how you store data inside one of this HDF5 format. So you create a data set, and then a data set, we create a data set for each font, and we say it's going to be this long, how many phrases we're storing by this many pixels in the Y direction by this many pixels in the X direction. I think that's right. Nope, other way around. Yes, no, that was right. That was right the first time. And we're going to store these in UNT8s. So I'm going to store a byte for every image. So I've got this many data points times 128 times 16. I've got that many bytes. So this should be about a gigabyte uncompressed, right? Because if I say math.log of that, 2, it's about 2 to the 30, which is a gigabyte. Uncompressed, but HDF5 tries to be smart about that. I'm pretty sure I might not have set that correctly. I don't recall h5py.file.create dataset. Do I have to tell it it's zip? Legal values are gzip, yada yada yada. String or in-compression strategy, yeah. Integer indicates the number of dynamically loaded. Name, shape, data, keywords. Keyword only arguments. Compression. So I might have been a terrible person and not compressed it well. I'm not sure about that, actually. Not so sure. I could probably look at the file and determine it afterwards. Anyway. Do I use I here? I don't think I do. I do. Only the data set. Sorry, mumbling to myself there. So that we're not going to run that data set since I already have the file on hand. But let's grab one of our phrases. I think I like this one. Is those whose something something, very Shakespearean. We don't actually need the I in this case, but I'll save it just for giggles. So let's just load it in as though we were creating the data set. So if you've got this font size, so recall this tells us how much space we're storing. And you see I've rigged the game here so that 16 characters is just about 128 wide, depending on what those characters are. Because our phrase right now is as those whose, so W is a big wide character in a lot of fonts. Not all fonts. Some fonts are mono width. What's the... I can't think of the right word right now. I'm an idiot. That's okay. Excuse me. Try to get comfortable here. Okay, but some fonts, they're not all centered in the same place, oddly enough. So you can get the offset of whatever font this is. So W and H here, these are just how big the the bounding box around this phrase is. And this is sort of how offset everything is from the center. Ooh, OH. So your sort of offset width and your offset height. So our offset width isn't so bad. We just get bumped to the left a little bit. Our height is 5 pixels, which is pretty significant. So we make sure to correct for that here. I just add those offsets in. There we go. And so now W and H are slightly different. And that's going to be where we're going to end up physically drawing our image, physically, digitally. So this IMG, so to use PIL, you've got to create an image. And image.new is generally how you do that. The L here just says, I want this to be a black and white, and the image size is how big a box I want for my image. So you take a look at image. That's cool. You can do image dot get pixel. Can I just do array on image? Can I do that? You can. So if I just do this, this should be 16 rows. That's how tall it is, comma 128 columns. You got to keep your X's and Y's versus your rows and columns straight here. That's got to be careful about that. If you said image.new question mark, you would learn what the possible colors you can do, like RGB images. I think I had to look up online that L was what I wanted. Okay, then you just draw. We say, okay, we're actually going to create a draw of this image. This is just sort of allocating space. We do that. And what can you do with draw? The same stuff, basically. What is bitmap, chord, ellipse, fill, font? So draw gives you a special object in PIL that you can do things to. Specifically, you can add text to it. Now, there's a whole bunch of stuff on this line. So what are we actually going to do with that? Well, so draw.text is how you say we're going to get some text. This first part is just the position. Let's actually just bring that up on the left. Nothing. What? Oh, that's awful. That's awful. Okay, this first part is the XY, where you want to center, I think, or is it just a generic offset? This looks like where I'm centering it. So I say whatever the image size is, minus the W. Oh no, sorry, this isn't the center. This is like the lower left or upper left corner. So I sort of split the difference between the image size and how much space it takes up. And then divide by 2 is what gives that to you. Both in the X and in the Y direction. Then you say what the fill is. So we're going to fill this with white pixels, I believe. Is that over here somewhere? And this all just gets passed to something else. Fill equals none. If ink is none, ink equals fill. Oh, so ink is none, so ink becomes our fill. So we're going to draw white pixels on a black background. Which is to say our pixel values will be very large, like 255, and the black background will be like 0. And font, of course, just pass in whatever the font is. And we saved our font is this funky object in image in PIL, so we can do that. So now we've done that. We've sort of stored that in whatever this image is, and then we can make it again. What? I'm confused that this is here and this is here. That's very weird. What is image then? Does image have stuff in it then? Hang on. What's the biggest value in here? Okay. So, right. IMG is allocated like the space for where we're going to store it. And then we said, hey, do something special with that space. Make a draw object. Then actually draw your text there. And then I'm saying make a new draw object, which seems wrong. A and B, I don't use that again. I don't think I need that. Anyway, after you've drawn it in there, now what we're going to do is just read that into a numpy array. But I want to read it the correct way. Let me import matplotlib.pyplot as plot, as I am wont to do. And we'll say plot.ion. And now imagine for a second that I just took whatever my image was and I said plot.pcolorMesh. You might look at that and you're wondering, what does that say? Well, there's a W. Oh, the W is up. Everything's upside down. That's not really how I want to work. You could train your model just as well, I suppose. But you really want to use this flip up down to get that. And I'm being, I guess, extra careful here, using from bytes and image.2bytes, but I don't think I need to do all that stuff. I think I just need to say, I wonder if I can just do flip up down IMG. Flip up down. What are you playing with today? Today is new research problem with Shakespearean text. Sorry, responding to chat. Do feel free to patronize the chat room. I try to respond to anything there. Oh, you totally can do this. Oh man. Plot.pcolorMesh. Oh, that's much better. That's much better. As those whose be. And of course, CMAP. It's plot.cm.gray. There we go. So that's the actual image. And you can see you've got some high values, but you got some other values that aren't. These are all black. There's some pure white ones, and there's some ones that are in between. And so this is sort of pixelated. You're like, oh, that's terrible. How can anyone read that? But if I did this, that suddenly becomes a little bit more legible. Still pixely. If it was like this, that's sort of like what you imagine, right? All right, so I don't even need to do. So that's a much easier thing I can do. Wow. So why did I do this other way? So this is an interesting question. Why did I do that way? I feel like I probably had it, because I would have tried the stupid thing first. B equals C. True. False in B equals C. False. Huh, they are identical. Alright, well, forget this silliness. So there was all this business with from string and taking to bytes, but you can just call flip up down on it. It interprets it as an array properly and stores that in this B business. And then finally, once I get it as an array in the fashion that I want, I just say, hey, the data set entry at this index, that equals B. Okay. So that's the data set that we're working with, that I created. You can make your own. You can grab whatever fonts that you want to grab. You can poke around in your own directories or grab ones online. You can use whatever corpus that you want. Get the Shakespeare from MIT or whatever. Now, let's make sure that we can read in this data. Datain.py. Globo17 asks, did I work as data science or just do this for fun as hobby? The streaming is definitely just for fun, just for giggles. and I like to teach. I've had some data science experience. I went to grad school for like civil engineering, believe it or not, but I was focused in transportation statistics, and I got involved in what was called econometrics, which shares a lot with machine learning techniques and, of course, my mind's blanking now, and data science, neural network type of stuff. It goes hardcore into like all the different ways you can do regression and classification, because in a lot of transportation engineering problems, A, you don't have that much data, and B, the data is insanely noisy. So you simply cannot build a good predictive model for a lot of things. And a lot of applications, you don't care if there's a good predictive model. If you're trying to predict crash statistics, it doesn't really help you to be able to predict, this road will definitely have 10 more crashes a year than this other road. You want to know why those crashes are happening. So that's why you really need to understand the weights that are on these parameters and other things that are called like marginal effects. And that's probably why I tend to focus on the weights. I always want to see, why is this model working the way it is? Some people are more comfortable using machine learning tools as black boxes. I'm not one of those people. I have to have, I gotta have the weights and know what the model is doing, or I go crazy. All right, so I don't need pill anymore. I don't think I need glob. So we've got font data.h5. Probably gonna need math, probably gonna need this, probably need all this stuff. Okay. So my data file is font data.h5. H5. And it is about a gigabyte. So that is what it is. We don't have to read it all in at once. With the H5, we can just sort of cycle through as needed. We should be able to read it all in, though. So right now, I've got lots of memory available. Shouldn't be a problem, right? Shouldn't be a problem. Tell you what, let's try to read in all the data, or at least a subset of the data. So H5. So actually, F equals, or H5F, I like. So I just want to read in with the data and fiddle around with it. And we were reading this, of course. And let's say D file in case we want to change that around. Yeah, last one used. Perfect. D file is not defined. That's what I get, man. That's what I get. H5F. Well, yeah. Dot. I don't want to create a data set. I want to read a data set. Get. What's 0? There's no attribute in code. Interesting. Dot values. So bound method mapping. That's probably not what I want. Pop parent update items. Require data set file. I was hoping, I should have paid more attention to this, that there was going to be a like get data set. Or like get list of data sets. What did I name my data sets? It's a good question. I didn't name them. I'm a terrible person. Int object has no attribute in code. Interesting. Alright, well let's look this up. H5Py read dataset. I haven't actually used H5Py that much, and I really should, because it's sort of the standard way to store these giant things. They say, hey, install with Anaconda. I didn't do that. I'm a bad person. That's for writing. I want to read. I want to read. Datasets? I don't want to create a dataset. No, no, no. I've got my data. I want to get my data back. Resizable? No. Let me back. Forget that. Datasets. That's a start. Read and write. Input and output. NumPy erased it. Yeah, that's definitely NumPy, I feel like it's just the gold standard of easy to use, stupid. It's a model of datasets and groups. You can load that up using create dataset 1. Okay, but how would you know what the keys are? If you suppose you open up a file. H5F dot. There's no keys, is there? Oh, there is. Derp, 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 derp. Keys view with lock. So if you're looking at it in one place, you can't look at it in other places. And there's items too, isn't there? Yeah. Okay, so it's got a dictionary-like aspect. Okay. In that case, I just wanted to goof around and grab one of them, you know? That's all I wanted to do. h5f.name / cute. Real cute. h5f.file name, yeah. h5f.id. Oh, hang on. What if I said keys? What if I said list? Give me a list of the keys. Yeah, now we're getting somewhere. I don't know, because keys view with lock object is just a little strange. What is that about? That is just, it's a set? Interesting. That's the only thing you can do. That's weird. Huh. So it's just a slightly different kind of set. Set as a finite iterable container. Return super keys. Alright, so you get no useful information here. Alright, so it's a dictionary. That's how we're reading it. So if I were to say, for example, k equals h5f.keys of 0, can I do that? Oh no, it's a set, so you can't do that. But if I make a list out of it first, then I could do that, yes. And then I could say h5f, okay. Surely, this will give me the dataset object. And if I could say 0, then I get the thing. If I say plot dot color mesh, whatever that was, I get my image. This is the 100T, you might recall. It's amazing how much harder it is to read text when it's all stretched out like this. When the ratio is off. I mean, you can imagine training a neural network to read text. And you would train it like this and it does a decent job. Well, this is super hard, wow. And then like you try to read it like this and it's going to do terrible if it has twice as many pixels in this direction. I wonder how well a model would even do if you did that. Or like here's, oh, well how would you even, because you're going to train a certain set of weights, presuming a certain size. So you could sort of like double the weights in the vertical direction. Or split them in half or something. And see how well it does in that case. That'd be interesting. Anyway, that's how we can access. That's how we can access our data for our given keys. All right, and I want to experiment and see if I can read in all the data. Width is h5f. And I want to read it into one giant thing. Can I ask the size of this? h5f dot, is there size? What about h5f? Okay. Does this thing have a size operator? Size, there we go. Shape. That's what I wanted. Shape. Yes. There we go. Okay, so that's interesting. So I actually want in data Got the same number of each. All right, here's what I want to do then. For v in h5f dot values, I don't care what the keys are at first. Shape equals v dot shape 0 count size and data 0 and data. We're just going to count up how many data sets do we have, and then we will say that shape equals n data comma v dot shape of 1 comma v dot shape of 2, because we'll still have the v from the final guy there. And then, oh, that didn't work. Right. Didn't have my auto indent on, so I'm mixing indentation levels. Normally when you're in IPython, that's great. Okay. So yes, we see we've got the 500,000, and I can see right away if I can allocate this much memory. Let's do a quick computation. It's a gigabyte, right? We determined, because it's this number times 16 times 128, right? Yeah, 1 gig. Just to not go crazy, there's that all again. Yes. So if I just say n equals data even equals we got zeros of size shape, and dtype equals numpy.uint 8. So I'm going to allocate all that memory right away. Bam, done. That's interesting. I thought that was going to take a lot longer, or at least cause me some trouble. Does it not actually? I guess it decided, yeah, you know, I didn't really need that yet. -1, comma 6, comma 4 equals 1. Interesting. I definitely thought I was gonna be ripped to shreds there. All right, let me remove that. Okay, data equals numpy.zeros, shape dtype equals numpy.uint 8. There we go. Okay. Now let us, got our data array. I want to for k comma b in. That's data labels, right? Numpy.zeros shape 0, comma length of, we're gonna do a one hot thing here. Bam. Bam. Dtype equals numpy.float 16, I think is the thing. Is that right? Let me close this. Numpy.float 16, yes. I don't need to hold a lot of precision in those. Yeah, there we go. Okay. So for key comma value in h5f dot items, so we sort of pre-iterate through it to allocate, figure out how much space we need. It's nominally a little slow, but that's actually pretty fast. As you saw, that took almost no time at all to do. Now we're actually going to have to go through, grab those items, I guess actually want to go through here too. Do this as items. Labels equals empty list. And then I'm gonna labels.append. I only have a few, so it's okay. There we go. Cur label, let's just call it label, whatever. Labels.index. Okay. Dang it. I accidentally killed it, as I am prone to do. Alright, so I grab whatever the current label is. Oh, I don't even need to do that, do I? I should. Righto, let me reset that, do that. Not a location ID, invalid object ID. Okay. What? Oh, derp. Because I had the file open earlier and then I closed it. Only H5F. Not close. Not a valid file ID. Alright, H5F equals. We'll open it up again. There we go. Now we've got these things in the labels, and all is well. Right, and if you say, for example, labels.index, I don't know, whatever this one is. Bing. You get 3. 0, 1, 2, 3, 4. 3. And we're at 41 already. Just keeping an eye on the time, see how far I want to get today as far as reading in the data in a sane fashion. If I can get the data read in without having any model, I consider that a win. Yeah. I need to keep track of what guy I'm on. X equals 0. So this is sort of for every font. This is get data size. One hot. Just add a couple things so that when I look at this in a week, I won't have to guess what those things are. So the thing is, V is the dataset object. V, and I say V of 0, say, that gives me an array. If I say V of all of these, that gives me a big array. I didn't actually want that. If I say V of the first 10, V of the first 10, yeah, that shape. So, here's what we're gonna do. I want data of index, right. Index times, that's dumb. It's dumb. I should use enumerate like a sane person. You can enumerate on dictionary, right? We'll find out. So I want to get the index as well as the index, the key, and the V. And the index is going to be the key, is going to be the label as well, but I'm being a little paranoid because you're not guaranteed to get those out in a particular order. Alright, so data of index times V dot shape 0 to index plus 1, not index, just I. So store off all the data equals. So we're going to store off the data from this particular HF5 into this array, this slice of the array. So the first umpteen, I say first. From this position, wherever we're at, right, so when I is 0, we're not getting anywhere. And these all have the same shape, so that's why I can get away with just calling v.shape. I don't have to store where I'm at in the array Equals v. V is not an array object. v.get. Oh, I think I can just say v like that. I've got the thing for v, I've got a thing for k. I can set I equal to 0 right now. Got data, it's this big... I don't have data. But Dan does data! Oh my goodness. I got shape. Yeah, there we go. I don't know if I have labels. Let's get labels going. Labels! Nice. And let me do this. Uh-oh. Labels.index. Oh, not labels. Son of a gun. Idiot. Alright, hang on. h5f.pose. One of these days. There we go. Open it up again. Let's see if I might not be able to read in, scan through the file twice. It might need to be like an h5f dot. Is there a rewind? Set default, pop item, visit items. What is visit? Recursively visit all names in this group and subgroups. I don't need to do that. That's like if you have a very complicated structure going on. h5f dot, clear, close, copy. I'm not going to worry about it right now. Del data, there we go. Del labels, just make sure, just to be pedantic. Alright, so this is label list. There we go. So now I've got to pick a label. 4. Great. So now I'm going to stash all my data into that. And this seriously doesn't soak up a crap ton of memory? No. I mean, it took some. Right? But not all the memory ever. So that's good. I think I can live with that. And then I want to say that labels of this same thing of this position equals 1. I want to set all those to 1. 1.0. Whatever. Okay. I actually think we're ready to do that. Let me just kill that. Redo this. Make auto indent happen again. Oh, hang on. Let me slap some TQDM on this. TQDM. Because I like that. And you can say total equals 5. Length of a label list if we want to be really careful here. Right. Let me just %run this. I don't normally do that. And of course, oh yeah, boom, boop, boop, boop. Very nice. And now I can import matplotlib.plot as .pyplot, excuse me. It's plot.ion. And now I can just say plot.pcolorMesh of whatever data point I want. Data of 2000, for example. There we go. For well thou know, probably is what it wants to keep saying. And I want to do cmap equals plot.cm.gray, right? Yeah, for well thou know. It's amazing how much easier it is to read again. We can grab a different one. So if we said this one plus, oh gosh, end data divided by 5. Yeah. This should be the next one. For well thou know, in a different font. Let me, just so you can see. Oh, son of a gun. And if we do an even further along one, that's a very different font. Wow, that's going to be a pain to read. That could be a challenge for the model, that particular font. Or it's a smaller font in general. For well thou know, yet another font. And the last one, for well thou know. I'm sure if I shrink this even more. They have different expected ratios, I guess, too. Yeah, I think that first one was pretty among the most legible. Let's look at that again. Oh yeah, look at that. That's nice and legible. I like that. That's good fun. Label list. Which one is that? This Foglitten, whatever that is. Okay, so we've got our data. It's read in. So now we've got labels along with it. Label 0. Labels, last one, as expected. So now we're sort of ready to begin whatever modeling we're going to do, but we only have a few minutes left, so I don't think we're going to do that. I'm going to let you know that I'm probably going to do this in Keras, because I find that's the easiest way to like sketch out a model and bang around with some different ideas. And we're going to be trying different things with that and seeing what works. The goal is to, or one of my goals, I should say, I want to be able to have a recurrent neural network that gets to look at a slice, maybe 16 columns at a time, and that's sort of one time step. And it looks at that, it turns its crank, and then it outputs that information, whatever the output of that is, to the next chunk. And it looks at the next 16 bits, computes some more things, and at the end you've hopefully accumulated a good amount of evidence, and then you spit out whatever the answer is. Keras might not be a great tool for this. I might end up switching to Theano or something else. This might be a little too specific or specialized for Keras, or might become a pain to do that way, but I'm pretty sure Keras could do something like this. And in this case, I've got a fixed image size, so we could try a basic model of just do the whole image, all the pixels, see what you get. And that'll work in a way in the areas, for example, where the one font tends to be very small. It'll be near the center. So its edges will be all 0, and so you know if you see anything there, it's not that font. If you see all zeros over there, it's probably that font. So that'll be one way that'll probably be a really strong indicator in that situation. This is kind of a good tagline for this video. For well thou know. Probably knowest is what it's going to be, actually. Knowest. So that'd be a good recurrent neural network to talk like Shakespeare. You see just a little bit of the phrase and you see where you end up. So for well thou know will be the name of this project. Trying to recognize fonts from Shakespeare. That's all I have for tonight. You guys have a good time. And as always, keep on data mining. Take it easy.